In section 2.4a, we're going to be focusing more on solving equations, but specifically, if you'll notice in our examples here, our equations now have variables on both sides. For instance, the x and the x on these two sides. And so before we start, we're going to have to understand how to best get the variables on the same side of the equation. Now, as we start, I'm going to circle the 8x because the 8x is the larger of the two variables between 8x and 6x. And my rule of thumb is always going to be to move the smaller variables over to the side where they are bigger. So, to do this, I'm going to subtract 6x from both sides. When I subtract 6x from both sides, that is going to give me a result of the 3 equals 2x minus 21. Now I want to isolate the 2x and get rid of the minus 21. To do that, I'm going to add 21 to both sides. Once again, my 21's cancel with the additive inverse property, leaving me just a 2x on the right side and a 24 on the left side. Now to isolate the x, I divide both sides by 2, which gives me a final answer of 12 equals x. Now I'm going to slide my paper over to the right side where I have my notes on the other side of the green sheet on page 26, and we're going to check this problem. Remember, when we check a problem, we recopy the original problem exactly as it was written, except replace the variables with parentheses. And so here I have recopied it exactly and replaced my variables with parentheses. Now I'm going to put in the values 12 for each of my parentheses. 12 times 6 is 72 plus 3. 12 times 8 is 96 minus 21. 72 plus 3 is 75, and 96 minus 21 is also 75. So the equation checks, and I know my value of x equals 12 is correct. Once again, we're going to move the small variable to the large variable on each of these problems. Let's look at problem 2. On our second problem, we're faced with a little bit different situation in that we have a 2 outside our parentheses before we start the problem. So, let's begin the problem by distributing the 2 to both parts of the inside of the parentheses. That gives us 2c minus 12 equals 9c plus 2. Now we're in the same situation as we were on the first problem. I'm going to circle or box the 9c because it's the larger variable. And then I want to say, how do I move the 2c over to the right side? Well, if something changes sides, it has to change signs. So I'm going to subtract a 2c from both sides. That's going to leave me minus 12 equals 7c plus 2. Now I want to isolate the 7c, so I'm going to subtract 2 from both sides. Negative 12 and negative 2 make negative 14 equals 7c. To solve for c, we divide both sides by 7, which gives us an answer of c equals negative 2. Once again, I'd like to check this problem, so I'm going to slide over to the right side and bring in my green sheet from page 26, and I'm going to recopy the original problem down. When I recopy the original, once again, I'm replacing the values of c with parentheses. And in those values now, I'm going to put the value of negative 2. Let's work this out. 2 times negative 8 equals negative 18 plus 2. Well, 2 times negative 8 is negative 16, and that equals negative 16. And so, our value of c equals negative 2 is correct. The check is very important to do as we ensure that that makes sure our answer is the right one. Let's look at our third example. I've chosen this third example specifically for the fact that we have a variable and only a variable by itself on the right side. Now, hopefully you remember when there's a variable all by itself with nothing in front, we put a 1 in front of that variable, realizing there's one m there. To eliminate that 1m, we're going to very simply subtract 1m from both sides. When we subtract that 1m, we'll have 2m minus 5 on the left. Then, on the right side, 1m minus 1m is actually 0. There's nothing left. Now we go about and solve the problem like normal. We add 5 to both sides. So 2m equals 5. We divide by 2 to both sides. So m equals 2.5. Let's take a look at our check again and see if this problem checks out. Rewriting the original problem, 3 parentheses minus 5 equals parentheses. And in those parentheses, we're now going to stick 2.5. 3 times 2.5 is 7.5 minus 5 equals 2.5. We subtract the 7.5 minus the 5, and that gives us 2.5 equals 2.5, which shows us it does work, and our answer of 2.5 is correct. Our last problem, as we look at it, is a matrix. Remembering that a matrix, we have to make sure that the matrix lines up each portion of the matrix with the portion on the other side. So here I've boxed in the top left. So I'm going to put a little big plus on my paper here, and we're going to work out each of our sections one by one. My first equation says 2x equals x plus 3. My second equation I'm going to circle in red. That means a plus 1 will equal 2a minus 4. My third equation I'm going to circle in black. That means 4x minus 1 equals 2x. And then finally, the remaining things is 6 equals 6 from the bottom two corners. Now, we're going to solve each of these equations by using the same method. On our first one, we subtract x from both sides. That leaves us with x equals 3, a fairly simple answer. On our next one, the a is smaller than the 2a, so we're going to subtract an a from both sides. That leaves us with 1 equals a minus 4. We add 4 to both sides, leaving us a value of a equals 5. On the bottom left, we're going to subtract 2x from both sides. Now I have 2x minus 1 equals 0. I add 1. 2x equals 1. And I divide by 2, and I get x equals 1/2. Our final part over here is somewhat special in the fact that it just says x, or 6 equals 6. This is always the case, and so we have 3 answers. The top left says x equals 3, here a equals 5, and here this x equals 1/2. These are different x values for the problem. So when we're solving problems that we have with variables on both sides, we're going to move the smaller variable to the larger variable, much like gravity is always going to pull the smaller object to the larger object.